India's first animated live tuition. Can you hear me? Okay, so please turn on your camera, everyone. Please turn on your camera. Okay, welcome to the session. Are you ready to learn maths? Okay, so do we have some new students today? Anybody? How are you? Yeah, I'm fine. What about you? Okay, any new students? If you are new to this class, can you please raise your hand? Any new student? Any hand raises, ma'am? Can we start polynomials? So we already started polynomials and you were asking for this like number systems, and we just taught polynomials halfway through and we just started number system, and now you are asking for polynomials. No way. After completing this, we can restart polynomials. Okay? Yeah. Okay, any new students? No. Yeah, so we were discussing chapter number 1, number systems, right? Yeah, so we were discussing chapter number 1, number systems, and we already discussed some properties of numbers, right? We already discussed about natural numbers, whole numbers, integers, then rational numbers, irrational numbers, and we solved some questions, and last class I gave you one homework, right? Yeah, and the homework was find 5 rational numbers between 1 by 2 and 1 by 3. Find 5 rational numbers between 1 by 2 and 1 by 3. This was the question. Did you solve this? Yeah, we have a hand raise.
Yeah.
Ayman, right?
Yeah.
Yes, Ayman.
Yes, ma'am, I solved the question.
Okay. So, can you please tell me the steps?
Ma'am, since the denominators are unequal, we'll have to make them the same.
Yes.
So we multiply both the fractions with the denominators. So 1 by 2 into 3 and 1 by 3 into 2.
Yeah, 1 by 3 into 2 by 2, like the numerator and denominator. Yeah, okay.
So we'll get the new fractions as 3 by 6 and 2 by 6.
Okay.
Now here we can, there are others, we can...
We have to find 5 numbers. Okay.
Yes, so we do 5 plus 1 which is 6, and then we multiply both of them with 6.
Okay, so 3 by 6 into 6 by 6 and 2 by 6 into 6 by 6. Yes, then?
Then we get 18 by 36 and 12 by 36.
Okay.
So from between 12 and 18, then it will be 13, 14, 15, 16 and 17, 5 numbers.
Yes. Divided by 36 is also there, right?
Yes, ma'am.
Yes. So 13 divided by 36, 14 divided by 36, 15 divided by 36, 16 divided by 36 and 17 divided by 36. These are the 5. Okay, can you say this actually? Okay, let me write it here. 15 divided by 36, not 15, 13 divided by 36, 14 divided by 36, 15 divided by 36, 16 divided by 36 and 17 divided by 36. These are the 5 rational numbers between 1 by 2 and 1 by 3. So everybody got this answer? Everybody got this answer? Yeah. So in the previous questions, the denominator was same. We have a question here. Okay, wait a second. Find 5 rational numbers between 3 by 5 and 4 by 5. So here the denominator is same and we have to find 5 rational numbers. So what we do is, we just, I have multiplied it with 10 and then, yes, that is also fine. You can multiply it with any number greater than 5. So here we need to find 5 numbers. So we can just take 6, 7, 8, 9, 10, any other numbers. Any number greater than 5 is enough. And usually we just take 5 plus 1, 6. If you take 3 by 6 into 10 by 10, and the other one is 2 by 6 into 10 by 10, you will get 30 by 60 and 20 by 60. So here in between this 20 by 60 and 30 by 60, you can find actually 10 numbers, but we just need 5 numbers. So you can just choose any 5 numbers and just write it. Okay, so any number greater than 5 is okay. Yeah, so these are the numbers lying between this 1 by 2 and 1 by 3. So this was the homework question. Wherever you have this question, such questions like 1 by 2 and 1 by 3, 1 by 4 and 1 by say 12, some questions like this, you can always take the LCM and make the denominator same. Okay, after that you can just proceed like the previous questions. You can just multiply the numerator and denominator with that number and just proceed. Okay, yeah, and now we were discussing about this representation of irrational numbers on the number line. We already represented root 2 on this number line. Now let's see how we can represent root 3 on a number line. And while discussing about this root 2, many of you were asking, can we use a protractor? Yes, we can use a protractor, and I have a video showing how to draw this root 2 using a protractor without this.
Ma'am on hand raise.
Yeah.
Ishan?
Yes, Ishan.
Yes, ma'am. So you said after we finish number system, we'll continue with polynomials, right?
Yes.
So polynomials is not coming for me, and we need to. I think I need to learn more about coordinate geometry and start the linear equations one. Ma'am, so my exams are in so once we start that, so like getting polynomials, I think we still have more to do.
Actually, here we just start chapter 1, chapter 2, we got like that. For this coordinate geometry, it is the chapter number is
3, ma'am.
3.
Yeah.
Okay, so you can do one thing, like the recorded classes are available on this YouTube. Like you can just ask the admin, just send a message. You can just get the link of previous year's classes, or you can just watch the videos available in the app. Okay, because
Okay.
yeah. Okay.
Okay, ma'am.
Yeah. Okay. We don't have irrational numbers on a number line in our syllabus. In some schools, it may not be there, but it is there for others. Yes, ma'am. Coordinate geometry is there for me. Okay. Yeah. So we will continue with polynomials anyway, and after that only we can start coordinate geometry. Okay. First, second, third chapter we will go like that only. Okay. Yeah, so representing irrational numbers, and while preparing for the exam, if you have any doubts, you can ask me. Okay, yeah, I will help you with your doubts, but here we will discuss like first chapter, second chapter, third chapter, like that. Yeah, representing irrational numbers on a number line. So instead of drawing a perpendicular line like this, okay, taking a point, then doing like this, cutting, then like this, we were drawing a perpendicular by Heron's formula we started in class. Okay. Yeah, instead of that, you can just take a protractor and you can just mark this 90 degree and you can just draw this root 2 and root 3. So let's see another video showing root 3, how to represent root 3 on a number line. But we have one more way to represent root 3 other than this one. We can also see that, and you can just take whichever method is comfortable for you. Okay? Yeah, yes sir. Root 3. Yeah. So first of all, we have to draw a line. Yes. And then mark the numbers. And then okay, here also we are using the same method. We are not using a protractor. We are drawing a perpendicular bisector. Okay, and yeah. We are drawing a perpendicular bisector there. Not perpendicular bisector. We don't want to bisect the line. We just have to draw a perpendicular line there. Bisection means it must cut the line. But here we are just drawing a perpendicular line. That's it. Okay. Yes. Okay, that line is 90 degree. Yeah, and now we have to mark 1 centimeter on that line. So we are taking that 1 centimeter and cutting a point there, an arc there, and now we are gonna join this 0 to that point, and this line or this length will be root 2. We discussed all this in the last class. So that distance will be root 2. Taking that as the radius, we are drawing another arc. Yeah, stop. When we draw another arc, please go back. When we draw an arc taking the radius, this radius, we will get root 2 in the number line. But instead of that, in order to draw this root 3, what we do is, yes, again we are doing the perpendicular line. We have to draw a perpendicular line there. Okay. So we are repeating the same steps. Instead of that, you can use a protractor, that is fine. Okay, I will show you another video. Yeah. Okay, a perpendicular line. And now again we have to mark 1 centimeter. Okay. And join that point. Then taking that on a compass or taking that as the radius, we have to draw another arc, and that will be root 3. Okay, this is one way to draw root 3. This is how we construct the square root spirals and all. But we have one more method to draw this root 3 on number line. Yeah, we can see one more video, sir. And also you can just refer this video if you are using a protractor instead of this perpendicular line and bisecting and all this. You can use a protractor. Yes, the second video.
Ma'am, on hand raise.
Yes.
Mass.
Yes, Mars.
What are the measurements?
What?
The measurements.
Ma'am?
The measurements to
Measurements. Okay.
yes.
Yeah. Okay. Sir, can you please play that video again? First video. Yeah. While discussing this root 2 in the last class, we already discussed this thing. So first of all, you just draw a line and mark the points, just like 1, 2, 3 to the right side and negative numbers to the left side. Negative numbers is not necessary. And taking this 1 or 1 centimeter, you have to draw a triangle actually. This is 1 centimeter and this is 1 centimeter, and here we are drawing or we are joining these two points. Since this is 1 centimeter and this is 1 centimeter, and again this is a right angle triangle, we have base square. Pythagoras theorem says that base square plus altitude square, base square plus altitude square is equal to hypotenuse square, and here the base is 1 centimeter. So 1 square plus 1 square is equal to the hypotenuse square, and 1 square is 1. So 1 plus 1 is equal to hypotenuse square, which implies 2 is equal to hypotenuse square, and therefore the hypotenuse will be equal to root 2. So what you have to take is, first draw on this point 1, you have to draw a perpendicular line 1 centimeter. Okay, this is 90 degree and this is 1 centimeter, and this is also 0 to 1, that distance is 1 centimeter, and join the 0 and this point. So this distance will be root 2. So what you have to take is, just take this 1 centimeter. Okay, this as 1 centimeter, and it must be perpendicular. That's it. All other measurements will be there. Yeah, now we can play the next video, and after that we will come back to this. Okay.
Ma'am, 2 hand raises.
Yes.
Neha.
Yes, Neha.
Ma'am, as we are discussing the rational numbers on the number line, I don't think this is there in other people's syllabus, because my teacher asked this question like by herself. It's like represent 9.3 on the root 9.3 on the number line. So can you explain that?
Yeah, we will explain this, but before that we have to make sure that everybody knows this root 2, root 3 and all this, and after that we will discuss this 5 plus root 3. We already discussed 5 plus root 3 just for you and some others, but we will discuss those questions. First of all, I have to cover the portions that are given in your textbook and the questions, and after that we will surely solve some extra questions like this root 9.3, then 5 plus root 3, 3 plus root 2. Okay, we can solve such questions. Yeah.
Ma'am, Abid.
Yes, Abid.
Yes, when you are constructing the number line, so you're making a triangle, you're making an arc. So what do you use the arc for?
Yeah, see, we have to mark root 2 on this number line. So for that, we need to take this root 2 on this compass and mark an arc. So that's why we are drawing 1 centimeter here, and here this is also 1 centimeter, 0 to 1. And when we draw this, this is actually root 2. And we are taking that distance in the compass, and then we are drawing an arc so that this point will be root 2. Okay, from 0 we are taking that distance in the compass and we are cutting it, so we will get root 2. Just like we took this 0 to 1 as a distance, and we constructed a line here, and after that we took 0 to 1 distance and we just marked an arc here just to draw this 1 centimeter. Just like that, to draw this root 2, we are taking this distance in the compass and we are drawing an arc so that we will get this root 2. Okay.
I'm like during the S, like the S below the that arm to during the semicircle, you with the compass you will do also.
Okay, you don't have to draw this full circle, just take this and you have to make sure that it is touching this number line, okay, at this point. We just need that point. The arc is not necessary, we just need that point where this arc touches this number line. We just need to mark this root 2. So you don't have to draw this full or half circle, just that portion. Okay?
Okay.
Yeah.
Ma'am, one more hand raise.
Oh.
Ayman?
Yes, Ayman?
Yes, ma'am. Actually, our teacher said that this topic wasn't much important, and she just showed us how to do 9.3 cube and root 5
Okay.
with a different method, that too.
Yeah, I will show you another method. Okay, yeah. Sir, Dadu, yes,
Ibrahim,
yes.
you want to show it now?
Okay. Yeah. Sir, the video. No. Other one, root 2 and root 3. Okay, we have another method to draw this. Yeah, please play this. Please join the class on time. Okay, yeah. And yeah, using a protractor without using that compass to draw this and cut this, you can use a compass. No, not a compass. You can use a protractor to mark this 90 degree. Yeah, and we need 1 centimeter. Yeah, so that's why we are taking that 0 to 1 distance and we are just marking a point on that perpendicular line. Yes, we are just marking a point on that perpendicular line, and that is 1 centimeter. Now we have to draw a line joining those 2 points, and taking that you can draw an arc. Okay, we just repeated the same thing, but instead of using this compass to draw all this, we just draw using a protractor. Okay, that is the only difference. And now we have to draw this root 3. For that we have one more method. Yes sir. From this root 2 you can draw a perpendicular line. Okay, and you can just take an arc, again 1 centimeter, and just mark that point or just join that, and taking that you can just draw another line, another arc, and that will be root 3. Okay, this is the another method. You can draw root 3, but for this construction of square root spiral we can use the other method. Okay, but here we can use this method. This is also acceptable. You can use from this root 2 you can draw a perpendicular line and just an arc, and you will get this root 3. Can you keep the sir, can you please play this video once again? Yeah, first of all we have to draw a line, and then yes, please go back. Okay, just place a protractor there, and yeah, and just mark this 90 degree, and you can just draw a line, but we need just 1 centimeter. That's why we are taking 0 to 1 distance, and we are just cutting a point there to understand or to identify this 1 centimeter length. And now from 0 to that point we are drawing a line. Okay, and that distance will be root 2. Okay, 0 to 1 is 1 centimeter, and 1 to that green line, it is again 1 centimeter. So using Pythagoras theorem, we have constructed a right angle triangle. This is 1 centimeter, this is also 1 centimeter, so this is root 2. Okay, so now taking that point in a compass, we have to cut an arc, and the point where this line touches or the arc touches, this number line is root 2. So that is root 2. Instead of using compass to cut this or draw this perpendicular line, we are using a protractor. That is the only difference. And in the first method, we just draw perpendicular line here. Okay, here, not here, yeah, here, right? But here we are just drawing a perpendicular line from root 2. Yeah, sir, please continue. We have to draw a perpendicular line at this point root 2. Yeah, so we are placing a protractor there and we are marking 90 degree. Please go back. Yeah, we are placing a protractor there and we are marking this 90 degree, and now we have to draw another line, and that too, okay, to mark this 1 centimeter, and then, okay, yeah. So taking that, you have to draw an arc, and the point where this arc touches the number line is root 3. Okay, this is another method. Now we can see how to draw. If you have any doubts, please do drop your messages in the chat box. Okay, now root 5. Okay, root 5. How to draw root 5? Again, we have to draw this line and we have to mark the points. While drawing this root 2, we just started from point 1. Okay, now we have to start from this point 2. Okay, yeah, yes sir, continue. From this point 2, we have to start. So there we have to draw a perpendicular line, and yes, we have to mark this 1 centimeter, and from that point you have to draw a line to the 0 or to the origin, yes, and taking that point we have to draw another arc, and that will be root 5. How this is root 5? Just see, here we have a right angle triangle. Again, we have a right angle triangle. This is 1 centimeter and this is 2 centimeter. What about this distance? Again, we can use the Pythagoras theorem. Yes, see, we have to mark root 5. And we have to mark root 5 and see what is this distance. We are taking that distance to cut an arc, right? I'm explaining why we are taking 2 centimeter. Just wait. Okay, so see, we have base square plus altitude square is equal to hypotenuse square. Altitude or the height. Okay, altitude square or the height square is equal to hypotenuse square, right? Here the base is equal to 2 centimeters. So 2 square plus 1 square is equal to hypotenuse square. What is 2 square? 2 square is 4. So 4 plus 1 is equal to hypotenuse square. That is hypotenuse square is equal to 5. 5 is equal to hypotenuse square. This implies that hypotenuse is equal to root 5. Okay, so this distance is actually root 5. That is why we are taking 2 centimeter. Okay, just like that. We learned a different way in school. Okay, you can use that method also. Okay, so here you can use this to draw this root 5, and if we are continuing this method, first of all we are drawing this root 2, then from that point we are taking this root 3 and we are drawing another line. Okay, and we are drawing this root 3, then we are drawing root 5. If we are continuing like that, we will get a square root, yeah, please remove that video. We will get a square root spiral like this. Root 1, root 2, root 3, root 4, root 5. We are continuing the process and we will get a square root spiral like this. Okay, it goes on and on. You can mark all the points, all the roots, and see this root 4 will be at this point 2 and this root 16 will be 4. Like that it continues. Okay, and you will get a square root spiral like this. Many of you have constructed a square root spiral in your school. You just told me like, we constructed a peacock spiral. Then, yeah, I just forgot. Last class you just commented your spiral. So you know how to make the spiral. So when we plot this, we will get a square root spiral like this. Okay. This is all that in your textbook, and we can solve extra questions. Okay, after completing the chapter we will solve extra questions. Like You told me like root 9.3, then 5 plus root 3. We can solve all such questions. Okay. Yeah, so any doubts about this root 2, root 3, root 5 and all this? Root 2 and root 3 are already there, and root 5 was there in your exercise questions. All other questions we can solve it. Okay, we will solve extra questions. Okay.
Ma'am, Chris.
Yes, Chris?
Ma'am, can you again explain how to mark the root 5?
Yeah, okay. Sir, can you please please play that video again? Okay, so first of all, just draw a line. Okay, and mark the point 0, 1, 2, 3, 4, etc. And while drawing this root, While drawing this root 2, we started from the point 1. Just because we just want to construct a right angle triangle with base and height is equal to 1 centimeter, so that we can get root 2 there as the hypotenuse, and we can take that root 2 on a compass and we can draw an arc to get this root 2 on this number line. But here we are drawing root 5. Okay, so for that we have to take 2 centimeter here and 1 centimeter here, so that 2 square plus 1 square is equal to this distance, or the hypotenuse square, using Pythagoras theorem. Pythagoras theorem says that base square plus altitude square is equal to hypotenuse square. So that's why we are taking this 2 square plus 1 square is equal to hypotenuse square, and that is why this 4 plus 1 is equal to hypotenuse square, and the 5 will be equal to hypotenuse square, and root 5 is equal to hypotenuse. So that we are taking this 2 and 1, 2 as the base and 1 as the height, just because we need to get this hypotenuse as root 5. Okay, that is the only reason why we are taking this 2 centimeter as the base and 1 centimeter as the height. Okay, so instead of placing this protractor at this point 1, we have to place it here at 2, or we have to draw a perpendicular line at 2. Yeah, so just place that and mark 90 degree, and you have to draw a perpendicular line there, but we just need 1 centimeter. 1 centimeter length is enough. So we are taking this 1 centimeter distance on this compass and drawing an arc. Okay, we are making a point there just to identify this distance as 1 centimeter, or you can just measure it using a scale. Okay. Yeah, so that is 1 centimeter. Now from 0 to that point we are drawing a line. Okay, so that distance will be equal to root 5. Actually, this distance is actually equal to root 5. Since this is 2 centimeter, this distance is 2 centimeter, and this distance is 1 centimeter. The hypotenuse is actually equal to root 5. Now just take from 0 to that point, just place a compass there. Yeah, yes sir. And just measure that distance, and taking that, just draw an arc. Okay, and the point where that line touches this number line is root 5. Okay, this is how we draw root 5.
Ma'am.
Yes.
Rishikesh?
Ma'am, in root 3, it will get root 2.
What?
Ma'am, that root 3,
Hmm.
that will get the root 2.
From root 3, we will get root 2. What
Yeah.
did you mean? After drawing root 2, we can draw root 3. From that root 2, from that point, we can draw a perpendicular line and just join that point and just draw an arc. You will get root 3. After drawing root 2, you can draw root 3. Draw root 3. Okay? Yeah. Okay. So this is how you draw root 2, root 3 and root 5. Yes?
Mitesh.
Yes, Mitesh?
Ma'am, but we can't draw root 3 directly, right? We need root 2 to draw root 3.
Yes.
Okay, ma'am.
Okay, so all these questions were there in your textbook, so that's why I solved this. Root 2 and root 3 were already given as some examples or something, and this root 5 was there in one exercise question. Okay, other questions we can solve. Extra questions we will solve, don't worry. Okay. Yeah, first of all we have to complete a...
One more hand raise.
Yes.
Ayman?
Yes, ma'am. So like for root 5, I think this one was more complicated, and like the one I did in my notebook is like easier.
Yeah, so what was your method?
So, ma'am, first of all about this method, like what are the measurements we need to take for this method?
This is 2 centimeter. Base is 2 centimeter, and this height is 1 centimeter. So you will get root 5 here.
Okay.
Ah.
And about that question, yes, I've done it in my notebook.
Okay. So,
Yeah, ma'am.
can you
So
please remove this
what we
video?
do?
Yes, Ayman.
Yes, ma'am. So what we do? Root 5, right?
Ah,
We get so what we do is we take root 5 as 5 equals 5 into 1.
5 equal 5 into 1. Okay.
Okay, then we then we draw a line from A to O, which is 5 centimeter.
Okay.
A to O, which is 5 centimeter, and then we draw another line, which is O to B, which is 1 centimeter.
Wait, so we have a line like this, and this point is A.
Yeah, A to B.
A to B.
No, I mean A to O, A to O,
Okay, A to O.
A to O, and then 1 centimeter O to B.
O to B. Okay.
Yes, ma'am. Then we draw a semicircle from we draw a semicircle from A to O.
A to
No,
O.
from A to B.
A
Draw a
to-
semicircle from A to B. Yes, and then that O line we see, we draw a straight line to like the top, and then we can say that OP, and then we get a new intersection point which is P, and then we can say OP is perpendicular to AO, right? 90 degrees.
Okay, so you constructed this line in such a way that this is perpendicular. Okay.
Yes, ma'am. And now what we do is that we take a compass, and we measure the compass from O to P, and then we draw a complete arc, and that is our root 5.
We take a compass and measure from O to P.
Look, I'll show.
Ma'am, can you please pin?
Now can you see?
Wait. So can you please pin this one? Okay, so yeah, okay. Okay, I mean, ma'am, can you please? Okay, thanks. Okay, I mean, you can follow that method. Okay, yeah. Yeah, that is fine. Okay. Yes. Okay, so yeah. Anyways. Okay, so all these questions were there in your textbook, like root 2, root 3 and root 5. We completed that. Okay, so we can complete the textbook questions, and we will come back to this. Okay, other extra questions. Yeah.
Niranjan?
Yes, Niranjan?
Ma'am, the method he just showed, ma'am,
Mm-hmm.
isn't it like I think so for that we need like a decimal root. Like for in our school, like sir took this topic today, and he said it's called like a decimal number the decimal root number on a number line.
Okay.
So like, would it be correct if we use a normal root?
I have to check that, Niranjan. Okay, I can now tell you about this method, and I have to check the other method. Okay. Yeah, and I will tell you in the next class. Yeah. Okay, guys. So we just discussed about root 2, root 3 and root 5. Now we can just solve some textbook questions, and we will solve extra questions later. Yeah. So now, and this is the square root spiral you were telling me about in the last class. Okay, you will get a square root spiral like this. This is not the end. You can just continue this. Okay. Yeah. Now let's see this. Okay. State whether the following statements are true or false. You can just tell me whether the statements are true or false. The first, okay, and you have to justify your answers. Why this is true or false? Yeah, every irrational number is a real number. True or false? Ma'am, can you please unmute someone? Every irrational number is a real number. True or false?
Anurka.
Yes.
It's false, ma'am.
Why?
It's true.
True.
Right.
Okay, true. Why?
Now, because real number consists of both irrational and rational numbers.
Yes, so correct
So-
answer. So real numbers is divided into rational and irrational numbers. So all irrational numbers actually comes under this real numbers. Yeah, very good. So this is actually true because we just know that real numbers is actually divided into this irrational numbers and rational numbers. So all the irrational numbers are actually rational, not rational, real numbers. Just take root 2. Root 2 is a real number. Then just take pi. Pi is a real number. So all irrational numbers are real numbers. Correct? Now every point on the number line is of the form root m, where m is a natural number. Okay, every point on the number line is of the form root m, where m is a natural number. True or false?
Azalfa.
This is false.
Why?
Because we can also represent decimal numbers on the number line.
Okay, so can you please tell me one example where this number is not of the form root m, where m is a natural number?
For example, there was a question in the textbook to represent root 9.3 on the number line.
Okay. Yeah. Others, why this is false? Can you please tell me one example? What about this? Okay. Tell me one example. Every point on the number line. Every point on the number line means when we draw a number line, we have 0, 1, 2, 3, 4 and we have this negative numbers. Negative 1, negative 2, negative 3. All these are there. Okay. Yeah. And the statement is every number on the number line is of the form root m. And in between this, we have this 1 by 2, 0.5, everything is there. Every number on the number line is of the form root m, where m is a natural number. Is that true? Root of 625 is equal to 25, which is a natural number. Yeah, but we have exceptional case. I am asking about, yes, negative numbers. Yeah, very good. Negative numbers, correct? It can be a negative, yeah. So just consider negative numbers and other numbers on this number line. You can just tell me one exceptional case is enough. So this is false. Every point on the number line is not of the form root m, where m is a natural number. This is a false statement. Now the third one is every real number is an irrational number. Every real number is an irrational number. True or false?
Nirmal.
Every real number is an irrational number.
Yes, ma'am. Ma'am, it's false.
Why?
Because real number is a combination of rational number and irrational number.
Yes. So when we take a rational number, like we are taking real numbers include, yeah, okay, very good. So when we take a rational number, real numbers include rational numbers and an irrational number. So in order to represent this real number, suppose we are taking a rational number, say 1 by 2. Okay, so every real number is an irrational number. So is 1 by 2 an irrational number? No, it is a rational number. So again, this is also a false statement. Okay, yeah. So any doubts? Any doubts? Or you just raise your hand to answer the question. If you don't have any doubts, please lower your hand.
Some hand raises are there.
Okay.
Durgesh.
Yes, Durgesh.
No, I don't have a doubt. Sorry, I forgot to.
Yeah. Okay. So any doubts, guys? If you don't have any doubts, please lower your hands.
Abid. Any doubt?
No. Okay. Yeah. So let's.
Abhineet.
No. No.
Any doubt?
No. Are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. Are the square roots of all positive integers irrational? So root 2 is irrational, we know that. Root 3 is irrational, root 5 is irrational, root 7 is irrational. What about the square root of all positive integers? Okay, yeah, just think about this and tell me. If you know the answer, you can raise your hand. Several examples of rational numbers in the form P by Q. Can you guess? Yeah, please scroll down. That is coming. Okay, next topic. Decimal expansion of, yeah, root 100 is positive but it is rational. Root 100 is, yeah, so root 100, root 4, root 16, root 25, all these are exceptional cases. Okay, root 100 is 10, root 4 is 2, root 16 is 4, root 25 is equal to 5. So they are all rational numbers. So are the square roots of all positive integers rational? No, they are not. If not, give an example of the square root of a number that is a rational number. All these are examples: root 100, root 9, root 16, root 25, root of any perfect square. Okay, you can just write root of any perfect square or just write some examples. Okay, root 100, root 4, root 16, root 25, root 9, root 81, all these are roots of perfect squares. They are all positive numbers. So we can say that the square root of all positive integers are not irrational always. Sometimes they can be rational numbers. Okay, yeah. And this is the next topic, real numbers and their decimal expansion. Here comes this terminating, non-terminating, recurring, then non-terminating, non-recurring. Yeah, how to identify whether they are like rational or irrational, and up to how many points we have to check for this recurring. Okay, in some cases they recur at after 2 decimal points, like 0.2222. That doesn't mean that all positive square roots are positive. I had confusion in that thing. See, the question is, are the square roots of all positive integers irrational? The question is different. You said, are the square roots of, this doesn't mean that all positive square roots are positive. No, not positive. They are not irrational always. Not positive thing. They are not irrational. You don't have the square root of negative numbers. You don't have to learn this now. It is coming for the higher classes. You have the square root of negative numbers. But in this 9th grade, you are only discussing about the square root of positive numbers only. Okay, and here the question is, are the square root of all positive integers irrational? Because we are only discussing about the square root of positive integers. Okay, we are not discussing about the square root of negative integers. We are only discussing about the square root of positive integers, and the question is, are the square roots of all positive integers irrational? No, they are not, because we have some exceptional cases. Square root of all the perfect squares. Yeah. Now, real numbers and their decimal expansion. So what is actually this decimal expansion? Suppose we have this 10 by 2. Okay, we will get 5 here. Okay, there is no decimal and all. But what about 1 by 2? Can we divide this 1 by 2? No, actually we can't. So what we do is we just put one point here. Okay, and we can put a 0 here. So we will get 5 times 2 is equal to 10, right? And the remainder is 0. So we get 1 by 2 is equal to 0.5, right? 1 by 2 is equal to 0.5. Yeah, that is the decimal expansion of 1 by 2, right? We all know that 1 by 2 is equal to 0.5. Just like that, we can divide all the numbers and find their decimal expansion. So is this decimal expansion has something to do with this rational and irrational numbers? If we have some numbers in root 2, root 3, we know that they are irrational. What about the 0.10, 12, 15, etc., etc.? How can we identify whether that is rational or irrational? Up to how many decimal points we have to check? Okay, so in some cases, it will be like 0.12 and it is ending. Okay, in some other cases, it is like 0.11111. Okay, so we just put a bar above this 1, just to know that it is 0.111, it goes on and on. Then in some other cases it is 0.123, 123, 123. Okay, repeating after 3 decimal points. Then in some other cases it is like 0.176789, and then 176789. So up to how many decimal points we have to check this? Yeah, so let's see. Find the decimal expansion of 10 by 3, 7 by 8 and 1 by 7. We have 3 rational numbers here, 10 by 3, 7 by 8 and 1 by 7. We have to check for the decimal expansion of these numbers. Okay, so what is terminating decimal? Yeah, I will discuss that. We are going to discuss about terminating and all. Okay, so let's wait. Please wait. Yeah, so first thing is 10 by 3. Okay, 10 by 3. How do we divide this 10 by 3? So first of all, we have 10. We have to divide this 10 by 3. Yeah, so is there anyone who is ready to tell me the steps how to divide 10 by 3? You all know how to divide 10 by 3, right?
Hedachi.
Okay, 10 by 3.
Hello, ma'am.
Hi.
Hello.
Yeah.
So first you need to write 9 and down of 10 and write 3 at up.
Okay.
Like, yeah, 3, 3, 9.
Yes, very good. And the remainder is?
10. 1.
1. Yes, very good. Yeah. Yes, ma'am. Okay. So,
Then add a point at the up
okay, we have to add a point there. Yeah. And we can put a?
and 0 beside 1.
Yes, very good.
Then again write 9.
Okay.
9 and 3 up.
3 above. Okay. Again, 3 3s are?
9.
9. Very good. And the remainder is?
1.
1. Okay. Now,
And it goes on like that.
yes, it goes on like that. We can again put a 0 beside this 1 and 3 3s are 9 and the remainder is 1. Again, it goes on and on like this. Okay. Yes, very good. So, it is 10 by 3 is actually equal to 3.33333. Okay, so you can just put a bar or a dash above that. So, it is 10 by 3 is actually equal to 3.3333. It goes on and on. Okay. So here see the reminders are 1, 1, 1, 1. Okay, see here the reminder was 1 and we just put 1 0 beside that. And here the reminder is 1. Here also the reminder is 1. So the reminders are 1, 1, 1, 1. And the divisor here is 3. Okay, sir, can you please remove that? Yeah, and here the divisor is 3 and the remainder is 1. Okay, remainder is 1 and the divisor is 3. So you can see that this remainder is less than the divisor, right? We will always get the remainder less than the divisor. Yeah, and we can also observe one thing. Okay, you know how to divide this, so I'm not going to explain this again. Yeah, so now let's divide 7 by 8. So here see remainder is 1 and 1, 1, 1, 1 and it is less than the divisor 3. Yeah, now let's divide. Okay, this is not ending. It goes on and on, right? 10 by 3 is equal to 3.33333. It goes on and on. It is not ending. Okay, if it is not ending, we can say that it is non-terminating. If it is ending at a point, for example, suppose we have 1 by 2. Okay, what is this 1 by 2? It is actually 0.5. We got the remainder as 0 and it is ending. 1 by 2 is equal to 0.5. So it is terminating. It is ending at a point. It is not going on and on. So it is terminating. Okay, it is ending at a point and here it is not ending. It goes on and on. So it is non-terminating. And this 3 is repeating. Okay, 3 is repeating. So we just say that it is non-terminating recurring or non-terminating repeating. Okay, so I will explain again. No, don't worry. This is not ending. So this is non-terminating. Okay, this is not ending, so this is non-terminating, and also this is repeating. This 3 is repeating, 3.3333, so it is recurring or repeating. Okay, yeah. And here we have next one, 7 divided by 8. Yeah, so can we divide 7 by 8? Is the second answer 0.875? Okay, let's see. What is 7 by 8? How do we divide the 7 by 8? Yes.
Yes, ma'am.
So what is the first step? Can we divide the 7 by 8?
Ma'am, we need to add 0 point in the
Yes.
in the top portion and write 0 together 7.
Yes, just beside
So
7.
that
Okay.
so that will be 8 above
Yes, 8 8s are
and 64
64, and the remainder is
6
6. Okay,
and we can add 0
we can add 0.
and we can add 7 as a
Top.
portion.
Yes, so 7 8s are
And 56
okay, 56, and the remainder is
4
4. Okay,
and we will add 0
0. Okay,
and 5.
5. 5 8s are
Yeah, that's about
40. Yes, very good, and the remainder is 0. So we can stop here. Yes, very good. So the 70 divided, not 70, 7 divided by 8 is equal to 0.875. It is ending, so it is terminating. Okay, it is ending at a point, so it is terminating. It is not non-terminating, it is terminating. Okay, it is ending at a point, so it is terminating. And now let's see the reminders. In the first case, we got the remainder as 0, then it was 4, and then finally we got 0. And the divisor here is 8. See, all the reminders are less than the divisor 8. So here the reminders are 0, 4 and 6, and all these numbers are less than the divisor 8. Okay, and it is terminating. Now, why is it 70 by 8? It is not 70 by 8, it is 7 by 8. Okay, see, 7 by 8. We can actually write a number here so that that number into 8 will give you some 7. Okay, if it was 8 by 7, yeah, you can do 1 into 7 and you can write a 7 here. But since this number is, like, wait a second, we call this number as the dividend, and since the dividend is greater than the divisor, we always put a decimal point here. Okay, after putting the decimal, we can always add 1 0. Not adding, we can just write a 0 just beside the 7. So it will be 70. We can then write a number so that that number into this number will give you a number less than or equal to 70. So 8 8s are 64. Okay, then you can just proceed. And in all the classes, I just read one comment. Okay, and in all the like after getting the reminders, you can just put a 0 just beside that. After putting this decimal point, after each subtraction, you can put a 0. Okay, just beside that reminder. Yeah, you know how to divide, I guess. I hope so. Okay. Okay. Anyways, so here it is terminating. It is ending at a point. It is not going on and on. It is ending at a point, but here it is going on and on. Okay, non-terminating. Non-terminating and repeating, and here it is terminating. Okay, it is terminating. Yeah. 7 by 8, it is terminating. Okay, now let's see the third one, and here it is 1 by 7. Why is it 70 by 8? But why the 0 next to 7? After putting a decimal point, we can always put up 0 next to 7. That is how we do the division. See, if it is, okay, what was the question? This is 7 by 8. Can you divide this 7 by 8 without putting a decimal point there? No, you can't. If the dividend is less than the divisor, you can't do that. If it is 8 by 7, yes, No need of putting a 0 or decimal point. You can just write 1 into 7 as 7. But if it is 7 divided by 8, you always have to put a decimal point here. And when you put a decimal point, you can always put a 0 just after that number. If it is, see, 3 by 4. Again, you can't divide this 3 by 4 without putting a decimal point. So after putting a decimal point, you can always put a 0 just beside that number. Okay? Yeah. So now the next one or the third one, it is 1 divided by 7. Yeah, who is ready to divide 1 by 7?
Abhirami.
Yes, Abhirami. 1 by 7.
Yes, ma'am. First, we're gonna add 0 at the top
Okay.
because 1 is lesser than 7.
Ah.
We're gonna add 1 to we're gonna 0 near 1.
Yes.
So you get 10, and then you'll do like at the top you write 1.
1.
And then minus subtract 10 by 7.
Yes. And the
then
remainder
you
is
get
3. Okay. Again
Yeah. You have the 0.
0. Okay.
And then like you subtract 30 by 28.
Okay, what about this number? We have to write a number here on the top so that that number into 7 is equal to a number less than or equal to 30. Okay, so 4 sevens are 28. And the remainder is
You get 2.
2. Okay.
And then you will add 0 near 2. And then at the top you write 2.
Okay. So 2 sevens are
And then 14.
14. Okay. And the remainder is
Remainder is 6.
6. Okay. Then again.
And then after that you will add on the top you will put 8.
Okay, before that we have to put a 0 here just beside the 6 and again.
0.
Yeah.
Yes, we will put 0.
Okay, then 8. 8 sevens are
8. 56.
56. Okay. And the remainder is
4.
4. Yes.
Yeah. And then you will put a 0.
Put a 0.
And then at the top you will write 5.
5. Yes. 7 fives are
35.
35. Remainder
Remainder is 5.
5.
And then your 5 you will write 0.
Sir, please remove it. Yes. 50.
And then at the top you will get 7.
7.
And then you subtract 50 minus 49. You get remainder as 1.
Okay. Can we stop there here or do we have to continue?
It's non-terminating, so it will come well, repeat.
Okay, so is it non-terminating, non-repeating, or is there a chance for this to repeat after this 1, 4, 2, 8, 5, 7? Is there a chance for this to repeat?
Yeah, there is.
Okay, so then after this we have to take, so let me write it here. After this 50, 49, we got 1 as the remainder. Yeah, so we can put 10 here. Okay, wait a second, Abhrami, I will come back to you. So 10 by 7. 1, 4, 2, 8, 5, 7. 7. Okay, yeah, after this, continue. We got 1 as the remainder and then we have to put a 0 here. Yes. Yeah, please unmute here, ma'am.
Ma'am,
Are you confused?
ma'am, can you hear me?
Yes, you are audible.
Yes, ma'am.
So we have to write a number here. That number into 7 is equal to a number less than or equal to 10. So it is 1, right? 1 sevens are 7.
Yes, ma'am, 1.
1 sevens are 7 and the remainder is 3. Okay. Then
Then we repeat. 14285
Yes. Okay. So this is 330 and the number we have to write here is the next number 4. 4 sevens are 28 and the remainder is 2. So it will be 20 and we have to take the next number here and this is 2 sevens are 14. Yeah. So see it is repeating after 0.142857. It is again repeating as 142857. We got till 142 but it is again gonna be 8. The next one will be 8, then you will get 5, then you will get 7. So what is happening here? It is repeating after this much decimal points. After 0.142857 it is repeating just like 0.14857, 14857, 14857. Okay, so this is actually, when you reach till here, you may think, no, it is non-terminating, non-recurring. It is not repeating. No, it is not like that. So how do we identify that? We have some methods to identify that. Okay, so here it is repeating and the reminders are 3, 2, 6, 4, 5, 7 and the divisor is 8. And it is actually not terminating, but it is recurring or repeating. Okay, so how do we identify that? We can identify that just looking at the reminders and the divisor. So after seeing the division of all this 10 by 3, 7 by 8, 10 by 3, 7 by 8 and 1 by 7, we can just observe some things. Okay, the first thing that we can observe is the reminders either become 0 after a certain stage or start repeating themselves. So here you can see that the remainder just becomes 0. After a certain point, it is 0. Okay, so that is the first point. The remainder either becomes 0 after a certain stage. Yeah, we have seen that. Or start repeating themselves. In the first stage, it was repeating. Yeah, 3.3333 and the reminders were 1111. It is repeating. The reminders were repeating. And here also, it is repeating after like a long, it is repeating. Okay, this 3, 2, 6, 4, 5, 7. Again, the remainder will repeat 3, 2, 6, 4, 5, 7. So, the reminders are either becoming 0 or it is repeating after a certain stage. That is the first thing that we can observe from this division. Then the second thing is the number of entries in the repeating string of reminders is less than the divisor. See, the number of entries in the repeating string of reminders is less than the divisor. In 10 by 3, one number repeats itself and the divisor is 3. In 1 by 7, there are 6 entries. 3, 2, 6, 4, 5, 7 in the repeating string of reminders and 7 is the divisor. Yes, see, here the divisor is 3, right? Divisor is 3. And what about the repeating string? It is actually, see, it is repeating the, in 10 by 3, one number repeat itself and the divisor is 3. So here only one number is repeating. One number is repeating and this 1 is less than 3. Okay, so here the divisor is 3 and only one number is repeating and this 1 is less than 3. And here, yeah, it is nothing, not repeating, it is just terminating. And now let's take this example. Here the divisor is 8 and how many numbers are repeating? 3, 2, 6, 4, 5, 7. It is again going to be 3, 2, 6, 5, 4, 7, the reminders. And this is 1, 4, 2, 8, 5, 7. Okay, see how many numbers? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So, 6 numbers repeating. Okay, 6 numbers are repeating and here the divisor is 7. Okay, divisor is 7. So, the 6 is less than 7. Okay, so 6 is less than 7. The number of, 6 numbers are repeating and that number is less than the divisor. The number of repeating entities is always less than the divisor. So here the divisor is 7. So you have to check at least 6 points. Okay. So 6 points. After 6 points, if it is repeating, yeah. If it is not repeating after, you have to do at least 2 more steps. if you got 14, 1 4 after this, yeah, you have to continue the step and check whether it is repeating. And after the sixth one, if you are getting another number, say 8 or some other number, yeah, you can confirm that it is not repeating. So you have to at least check for the six numbers, at least check for this at least 6 digits, whether they are repeating or not. Okay, so that is the second statement. The number of entries in the repeating string of reminders is less than the divisor. Okay, the number of entries in the repeating string of reminders is less than the divisor. In 10 by 3, only one number repeats itself. So in 10 by 3, we got the reminders as 1, 1, 1, 1, 1. So only one number was repeating, and in 1 by 7, 6 entries, 3, 2, 6, 4, 5, 7, 3, 2, 6, 4, 5, 7, that were the reminders. And the 6 reminders were repeating, and the divisor was 7. So 6 is less than 7. So you have to check at least if we are dividing a number by, say, if we are dividing a number, say 16 or some number divided by 12. And here the divisor is 12, right? So we have to check for at least 11 numbers, not 11, 12. Okay, so at least after this 11 points, it can again repeat. So you have to check for at least 12 numbers. If it is repeating, yeah, you can confirm. After taking this 12th one, you will get an idea about this. Okay, that is the second thing we can observe. And if the reminders repeat, then we get a repeating block of digits in the quotient. Okay, if the reminders are repeating, we will get a repeating quotient also. Okay, here this 1 was the reminder. The reminder was repeating 1, 1, 1. So here also we got a repeating block in the quotient. And here the reminders were repeating, like after 3, 2, 6, 4, 5, 1. The reminders were again repeating as 3, 2, 6, 4, 5, 7. That is why we got a repeating block here in the quotient 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7. So if the reminders are repeating, we will get a repeating block in the quotient also. Okay, this is the place where we write the quotient. So if the reminders are repeating, we will get a repeating block in the quotient also. Okay, these are the 3 things that we can observe from the division of these 3 numbers. Okay, yeah. So here we have seen a terminating one. This is not terminating. This is non-terminating recurring. Okay, non-terminating recurring. And the second one is terminating. And the third one is non-terminating. Again, non-terminating recurring. Okay, non-terminating recurring. Yeah. And we have one more thing, non-terminating, non-recurring. But these two comes under the set of rational numbers. The terminating ones and non-terminating recurring ones, they actually comes under this rational numbers. And we have one more thing, we will learn about that in the next class. Non-terminating, non-recurring. Okay, both are non-terminating, non-recurring. And that is coming under this irrational numbers. Okay, yeah, now you can ask your doubts. Okay, ma'am. Exam time. Yeah, before that, if you have any doubts, you can ask me.
Ritesh?
Any doubts?
So that 7 by 10, one second.
7 by, no, 1 by 7.
Yeah, sorry.
Ah.
7 by 1. In this, how is the divisor 8?
Divisor is, oh, okay, divisor is 7, sorry. That was a typing mistake. Divisor is 7, yeah. Okay. Any other doubts? Yeah, again see this 1, 2, 3, 4, 5, 6. Okay, 6 is less than 7. Yeah, so that is correct only, but that was a typing mistake. Sorry for that. Okay, ma'am, sir, next, any other hand raises? Yes, Abid. Any doubts?
No.
No. Okay, any other hand raises?
Rishikesh?
Yes, Rishikesh?
Ma'am, it is a non-terminating and recurring number.
Ah, yes, non-terminating and recurring. Yeah. Next
We
one.
didn't write this.
What?
We didn't write this.
Okay. Next one.
Ashlyn,
Yes, Ashlyn.
Ma'am, you told root n can be also negative. It can't be negative, right? Because even if it is minus into minus, it will always be plus, right? So
Root
then
of,
can I-
okay, see, if it is negative 2 into negative 2, that is, yeah, positive 4. But root of negative numbers, root of negative 4, it exists, but you don't have to study about that. It goes to this imaginary numbers. Root of negative 1 is I. Please don't mess up with that. Okay, root of negative numbers exist, but you don't have to study about root of negative numbers. That's it. Okay, it's there. Yeah. Complex numbers, imaginary numbers, higher classes, you can learn about that. Not in 10th, in 11th. Yeah, 11th, it is there. Okay, next one.
Neha,
Yes, Neha.
Ma'am, 9.3, root 9.3.
Neha, we can discuss such questions after this. Do you have any exam?
Oh no.
No,
It's
okay.
okay.
Yeah, okay, simply. Yeah, I will discuss that. First of all, I have to complete that questions given in the textbook, like all these and okay. Let me see. Next
Okay.
class we can discuss. Okay, let's see.
Yeah, okay.
Yeah. I'm still getting confused in recurring and non-recurring. Can you explain again? Okay. See, suppose we just divided a number by another number and we got 0.323232, okay, or we got 0.1111. So it is repeating. After this decimal point, it is 0.1 is repeating, and here 323232 it is repeating. But if we got something like 0.18692496123 some numbers, random numbers, so this is not repeating or non-recurring. Okay, this is not repeating, or we just say that it is non-recurring. Okay, non-recurring, and this is recurring because one number is repeating and here two digits are repeating. 3232 it is repeating, no? And this repetition, this block of repeating numbers can be, okay, it can be 0.12345 and again 12345 12345. So a pattern is there. After this 12345 yeah, it is repeating. So if it is repeating, a block of numbers or a set of numbers is repeating after this decimal points, we call it as a recurring decimal. Okay, if it is not repeating, we call it as non-recurring. Okay, non-recurring. Yeah. Okay, so now it's exam time. Any other hand raises, ma'am?
Rahan,
Sir, can you please inform exam time? Yeah.
Ma'am, in the example just showed 1, 2, 3, 4, 5, 6. I had this doubt like what if 1, 2, 3, 4, 5, 6 and then if 1, 2, 3, 4 and then like 1, 2, 3, 4 and then 6. So like
Okay,
won't it get confusing?
0.12345 then 1, 2, 3, 4, 6. Yeah, 5 is missing. No, it is not repeating.
Yeah, like while doing it, if we since 1, 2, 3, 4 is repeating, like won't it be confusing for? Won't it be confusing?
Yeah, see, if the same block of digits is repeating, that is recurring. But here, if a single digit is missing, that is non-recurring. Okay.
So we have to like divide the thing.
Divide
divide
until, yeah, see, that is the second point. Here, the second point is the numerator or the, a number of entries in the repeating string of reminders is less than the divisor. So here, the divisor is 3. So you have to check for at least 3 reminders. Not 3, after 3, 1 more. Okay, here, this is repeating after 1, 1, 1, 1, 1. So you don't have to check for the other ones. 1, 1, 1, 1 again. And here, since the divisor is 7, you have to check for at least 7 reminders. Here at like 1, 2, 3, 4, 5, 6. Up to the 6, it was not repeating. Okay, so after this 6, you have to check for one more number. And if you got it as 3, check for the next one. Yeah. 2, you will get the reminders like this. The reminders are repeating. So you have to check for at least this numbers equal to the divisor. Okay, so the reminders will repeat at least up to this less than 7. So at least 7, and you have to check for 7 reminders if the divisor is 7. If the divisor is 13, check for 13 reminders. It may repeat after this 12th one. So the 13th one, okay, 1, 2, 3, 4, 5, 6, like 12. Up to 12th reminder, it was different. But from the 13th reminder, it is same as the first one. 13th reminder is same as the first one. 14th reminder is same as the second one. And the 15th reminder is same as the third one. Just like that, it can repeat. Okay. So at least up to the number of devices you have to check. Okay. Just like equal to the divisor, up to that much the reminders you have to check. Okay. Yeah. Okay, exam. Any other hand raises?
Yes, ma'am.
Okay.
Mitesh?
Okay.
Can you please read 0.12? 0.12.
Yes, 0.12.
Yeah. If it repeats like 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6.
That is non-recurring. If 0.121212, yeah, that is repeating or recurring. If it is 0.12, 1, 2, 3, 1, 2, 3, 4, that is non-recurring. Same block of digits must repeat. Okay. Yeah.
Ruben?
Yes, Ruben.
Hello, ma'am, can you hear me?
Yes, you are audible.
Ma'am, I have a doubt in the true or false number. Every rational number is a real number, or was a real number, every real number was a rational number? Can you show me that?
Yeah, this one. Okay, see, actually this real numbers is divided into rational numbers and irrational numbers, right? Okay, so when you take any rational number, it is always going up. Every rational number is a real number. Every irrational number is a real number. But it never goes down. If the statement is every real number is a rational number, that is wrong. If we take every real number is an irrational number, that is also wrong. See, every real number, okay, if the statement is every real number is an irrational number, and we know that real numbers consist of rational numbers and irrational numbers. So real numbers consist of the numbers like 1 by 2, 1 by 3, and it is also consisting of root 2, root 3, pi, and all this. Okay, so if we are saying that all real numbers are irrational numbers, it must consist only this root 2, root 3 and pi, all such irrational numbers. But we know that 1 by 2, 1 by 3, all these numbers are there. Suppose we are saying that all real numbers are irrational numbers, what happened to this 1 by 2, 1 by 3? It was there. It was a part of real numbers. So that is wrong. All real numbers are not irrational numbers. It never goes down. The arrow never goes down. It always goes up. All rational numbers are real numbers. Yeah, that is correct. All irrational numbers are real numbers. Yeah, that is also correct. But the arrow never goes down. Okay. Ma'am, can I see? Is it okay?
Yes.
Okay. Next one. Any other hand raises?
Any more doubts?
No. Okay, now it's time for exam. Okay, sir. Exam link. Ma'am, can you please scroll down? Yeah. So the first question is, you know how to attend the exam, right? Yeah. Just paste. Which of the following statement is true? Every rational number is an irrational number. Every real number is a rational number. Every rational number is a real number. One is an irrational number. Which one is true? Between any two rational numbers, there are dash rational numbers. Infinitely many, only 1, 5, none of the above. Then which of the following is an irrational number? Root 16, root 12 by 3, root 12, root 100. Which of the following is an irrational number? Which of the following is an irrational number? That is the question. Read the question carefully. Which of the following is an irrational number? Okay. 0 is I didn't get the link. Please refresh your page. A 10 by 10, okay. 0 is dash number, irrational, rational, neither rational nor irrational, not defined. Which of the following is a rational number? Root 7, root 25, root 23, root 13. So here, which of the following is a rational number? Okay. 10 by 10, okay, very good. If you didn't get the link, please refresh your page. Just minimize your Zoom and there you can see this link for exam. If it is not showing, just refresh your page, and still not showing means just log into the website. Okay, you are entering a website for attending the class. Just log into the same website. Then just below this link for class, you can see another link for exam. Okay, we can discuss the questions, then you will understand your mistake. Okay, wait. 10, okay. Okay, shall we discuss? If you are still attending, please raise your hand. If you are still writing the exam, please raise your hand. Any hand raises, ma'am?
Yes.
Okay. So let's wait for them. You were asking me. Why you are asking them? Just chat. Nothing is coming. Just deleted the message. Maybe. Who was that actually? So, which of the following statement is true? Every rational number is an irrational number. See, we have this real numbers, we have this rational numbers, then we have irrational numbers. Okay, the arrow never goes down, it always goes up, right? Okay, so every rational number is an irrational number. Rational and irrational, different extremes. Okay. Yeah, rational numbers and irrational numbers, two different categories, right? Yeah, so every rational number is an irrational number, that is a false statement. Every real number is a rational number. The arrow is going down, right? Real number, rational, yeah, that is false. Every rational number is a real number, yeah. So the arrow is going up. Rational number is a real number. Then 1 is an irrational number. So which statement is correct? Option number 3, yeah. Every rational number is a real number. Okay, third option is correct. Third and fifth question, let's discuss. Between any two rational numbers, there are option number infinitely many. Okay, I just put this 5 because in most of the questions, the question is to find 5 rational numbers between 1 by 2 and 1 by 3. So I just put that just to confuse you. But you guys are really good at this. Yeah, wait a second. Between any two real numbers or any two rational numbers, there are infinitely many rational numbers between any two given rational numbers. We have seen this in previous classes. Yeah, okay, so the answer is infinitely many. Okay, between any two rational numbers, there are infinitely many rational numbers. The third question, which of the following is an irrational number? Option number, confused? Option number, is that 3 or 2? 4. Huh? How many? 3. 3. Okay, why is it 3? See, what is root 16? Root 16 is equal to 4. Then root 12 by 3. 12 by 3 is root of 12 by 3. What is 12 divided by 3? 4 3s are 12. So root 4 and that is equal to 2. And root 100 is 10. So the only irrational number here is root 12. While discussing this true or false statements, we discussed every number. Okay, wait. After that, we solved one question. Are the square roots of all positive integers irrational? No. And we just saw some examples: root 25, root 100, root 4, root 16. All these were the examples that we have discussed here. So you can use the same thing or same. Yeah, third question. This is the third question. Is it clear? Root 12 is the only irrational number present here. Okay, root 16 is equal to 4. Root 12 by 3 is root 4, that is 2. Then root 100 is 10. So root 12 is the only irrational number. 0 is rational, irrational, neither rational nor irrational or not defined. 0 is rational number because we can write 0 by 1, 0 by 4, 0 by 100, any number. Okay, P by Q form. P by Q form where P and Q are integers, prime to be precise, and Q not equal to 0. Here Q is not equal to 0 but P is equal to 0. That is okay. Yeah. Then which of the following is a rational number? Option number 2. Because root 25 is 5, all others are irrational numbers. So the only rational number here is 5 and here the only irrational number is root 12. Okay? Yeah. Any doubts about these questions? Helmi Jafar. Any doubts? I found where I made mistakes. Okay, fine. Ma'am, here we have a hand raise. No. Okay. So is it clear? All the questions? Okay. Don't worry about the extra questions. Root 9.35 plus root 3. All this we will discuss. Okay. Yeah. First of all, let's solve some easy questions and then we can solve some difficult questions. Yeah. Okay. Anyways, see you all in the next class. Until then, take care. Bye-bye. Good night.